we'll go ahead and get started. Okay, let's see. My screen share has been acting kind of weird today, so let's see if I can get this going the right way. All right, so here we are from yesterday. We ended right here, so I'm going to go ahead and go on to the next one. More of solving radical equations. Okay. So let's go ahead and start off with number 9. And from yesterday, remember we were saying that you should isolate the radical first. You don't really need to, but it simplifies things a lot when you don't have to worry so much about using FOIL and combining like terms. So it's just an easiest way to do things is isolate your radical first. So that's what we're going to do. We're going to get this 1 out of here. So get a nice radical going. 2x minus 3. Get rid of that. And minus 1 from both sides. So 3 minus 1 is going to be 2. There we go. Now we've isolated our radical. Next thing we need to do is get rid of that radical because we can't really work through it. We're going to have to get rid of it. So I am going to do the opposite. And if you remember, the opposite of a square root is to square it. So I'm going to square both sides. By squaring the square root, it clears it up. So now there is no more square root. Goodbye, square root. But I also have to square this side, so be careful. So 2 square is 4. From here, it basically turns into a regular algebra problem. So something you've been doing for a long time, hopefully since 7th grade or so. I think some people get it a bit earlier, but from here, just follow your regular rules of solving algebra. Plus 3, because we got to, again, get that x by itself. So I got to get this 3 out of here. So get that 3 on out of here. And I'm going to have to add 3 to this side. So I get 4 plus 3, which is 7. Now what number can I multiply by 2 to get 7? All right. Now, if I say it like that, sometimes I'll get students that'll say 3.5, which is okay. I'll just go with that. I think people are probably more familiar with calculators than they are with fractions. So 3.5. Oh wait, before we box it, we have to get into that habit of checking it. So yesterday I was telling you that you should always check these, especially if you have radicals, and there are some other kinds of exercises that you should always check your answers with, because sometimes it is possible to do all the right steps, follow the directions exactly, but you just don't get the right answer, or actually there is no right answer sometimes. What we call an extraneous solution. So let's go ahead and plug this back in and see if it works. So 3.5, double it. So 3.5 times 2 is 7. 7 minus 3 is 4. So 4 is the number under the radical here. Square root of 4. So the square root of 4 is 2. So all this becomes 2. 2 plus 1. Well, 2 plus 1 is 3. So that makes this a solution. It is correct. Now, a solution, like if you have a problem, a solution is always something that will make it work. So for instance, if your car won't start, is changing your tire going to help? I mean, it's not going to make your car start, so it's not a solution. It is something that will improve your car, but for the particular problem you're looking at, it's not really going to do anything for that problem. So a solution is exactly what you need to put in there to make the equation balance out, because that's what it has to do. You have to make it balanced. All right, now moving on to number 10. Same thing, I gotta get this 6 out of here. And we gotta get rid of that 6 because we need to isolate this. We gotta get that cube root by itself. Y minus 4. And then 9 minus 6. 9 minus 6 is going to be 3. All right, now we still have this cube root. So if we want to get rid of a square root, we square both sides. But if we want to get rid of a cube root, we need to cube both sides. So if we were to square both sides, it wouldn't really have helped out. We have to cube it. Because again, don't forget what this means. What number can you subtract from 4, take the cube root of it to get 3? So cancel, cancel, because they're inverse operations. So again, it's like working backwards. This is like a puzzle ball or some kind of complicated box that's locked. You know, you got to do a certain set of things in order to unlock it. All right, so 3 times 3 times 3. So I have 3 cubes, that'd be 27. And I still got to get this y by itself. So this 4, we have to get it on out of here. Move that 4 over by adding 4 to both sides. 4 cancels over here, becomes 0. Y equals 31. And let's check it really quick, just make sure it works. So I would write the whole thing out, but I'm using the mouse. So 31 minus 4, so I'm plugging it in here. 31 minus 4 is 27. And cube root of 27 is 3. So all this becomes just 3. 6 plus 3 is 9. 6 plus 3 is 9, that is true. So this is a solution. It will work for what we need it to do. All right, give you a second or two to copy that down if you need it. All right, now we're gonna finish this one up, and this will be the last one we're gonna do for our review. Then we'll move on to the lesson that we're doing today. All right, and then just a heads up, I changed a couple of these. Like we're supposed to work on this one, but I changed it after this morning. The homework packets you got last week for this week's assignments have a little bit of a difference between those problems and the problems in the slides, the ones we're looking at right now. So they might not match. Homework and our lesson here might not match entirely. I changed a bit of it to make it work more closely, but we do have in this thing here, we're gonna have different problems, and I did that. I removed a lot of the complicated problems or problems with tricky solutions because I didn't want students who are by themselves to get frustrated and just sort of stop. So I kind of removed a little bit of them from the homework, but I didn't update the slides to match that. So we are gonna have a little bit of a difference, but this is a page, let me move over to there really quick just to show you which homework it is. So just a reminder, that's this page here. It's the one that says practice set solving radical equations. And it's on the back side of multiplying radicals. All right, so again, make sure it's that one. The one before that was to be this one here, individual work solving radical equations. So again, make sure you're working on the right one. Okay, now let's go ahead and get this last problem for this. I'm gonna minus 30. Because again, I want this to go, I want the radical to be by itself. Even though it's not a radical just yet, I'm gonna have to turn it into a radical. So minus 30 from both sides. And I'm going to convert this to a radical at the same time. So q plus 30. Now I'm gonna leave it in the parentheses for now. So remember, we almost every single day this lesson, like almost every single day since school started, we've been moving these into radical form. So I'm gonna put the 6 right here, and we need to take the root of it because of this bottom number here. That bottom number means we're taking the 5th root, so that becomes our index. Okay, now this 30 is gone, which is good. We want our radical to be isolated. And here I get 4,126. Let's see, 6 minus 0 is 6, and 2 minus 3, well, actually this would be 12 minus 3. 12 minus 3 is 9. Ah, there we go. Okay, now with this one, it's another kind of weird one, but I think some of the answers in your homework might be like this, so I decided to go ahead and add it. Because sometimes you don't get nice whole numbers, so I had to try to find one where you may not get whole numbers in the answer. As I say, sometimes it be like that. Okay, now we gotta get rid of this 5th root and this 6th power. And you do have a little bit of an option. You can put the 6 on the outside or the inside. On here, I just picked on the inside. I don't know if that's going to make, you're still going to get the right answer, but difficulty-wise, I don't know how much different that's going to be. And now I'm going to go ahead and take the 5th power of both sides, so power it by 5. There's not really a word for that, so we just got to say 5th power. Raise it to the 5th power. And that gets rid of this radical. So my radical with the 5th index is no longer there. We used it. It's been evaluated. And I have 4,096 there, but it's also to the 5th power. Now, I could use my calculator and get a really big number. Okay, it's going to be massive. It's going to be like huge. It's going to be like, I don't know. It's probably going to be like, you know, it's going to be pretty big, but don't worry. I'm going to show you 2 ways to do this. One way is if you have a calculator, and the other way is if you don't have a calculator. So I'm going to leave the power on the 4,096 just like that. And I'm going to root 6 on both sides. So root 6, root 6. So root 6, that will cancel the power of 6 out. And now we end up with some kind of weird thing. Okay, extend that out. Minus 30 from both sides because I need a minus 30. So if you don't have a calculator, this is probably going to be the way it's going to be, your answer is going to be written. So Q equals 6th root 4096 to the 5th power minus 30. So don't worry about simplifying it. In this case, there is just so much work to do. If you had to simplify it, it would hardly be worth it. So if you don't have a calculator, just go ahead and stop right here and leave that as your answer. Or if you do have a calculator, the best one I know of is going to be Desmos. But again, I know not everybody has internet. Not everybody has the ability to get the one they're the work they're looking for. So let me go ahead and just punch that in. I already have mine set up. In fact, let me just start from the beginning so that way you can see how we did it. So I'm going to go to functions, all the way to the last tab, miscellaneous, and then en route. So let's see, I'm going to have to plug that in as we saw it. So this one allows me to put the index in there. So I need the sixth index. And I will also need a fifth power. So to type in the fifth power, you're going to push Shift on your keyboard and 6. Shift 6, and it's a little symbol that kind of looks like an upside down V called the caret button, and that means to the power of. And we actually do manage to get the number 1024. And again, if you don't have a calculator, you can leave it like this. But in this case, it would be 1024. Go back to the slide. 1024 minus 30. And Q, if you again have the calculator, it would be 994. Let me double check that. Yeah, that looks about right. So there you go. Some of these you just have to leave them like this because again, I don't expect people to be able to sit there and calculate sixth roots of numbers that are already the fifth root and are already in the thousands. So either of these answers will be acceptable. Okay, so that's it for our review. Ooh. So let's go ahead and go on to what we're doing today. So we're doing more with solving radical equations. Oops, skip the bell work. So we're going to work some more with these rational exponents and solving these radicals because we're going to have to turn these into radicals in order to solve them. So take a second if you need to copy these down. Ooh, hot day today. Well, I don't know if it's particularly hot today, but I had to stay outside for a little bit. Alrighty. So I guess we can go ahead and get ready to do this first one. We still want to isolate those variables, the radical expression. Even though we don't see a radical expression, it would still kind of count as one. So I'm going to have to minus 4 from both sides. And so I get 2x to the 3/2 power. And here I get 686, like that. Now from here, we can divide this, oops, where did I get 3 from? Divide this by 2. So I'm trying to get this as close as I can, as isolated as I can. I can divide this by 2 and 686 divided, oh, excuse me. So x and convert it. So x to the 3rd root. So remember your bottom number becomes the index, and this would be 343. But I am still going to need to get rid of this root, square root, and this cube. So I'm going to have to, I could cube both sides and then root it, or root both sides and then cube it. But I think I'm just going to stick with what I've been doing, and I'm going to square both sides. And again, if you have a calculator, you can easily just punch that in and see what you get. So here I have x to the third. I'm probably gonna have to write a little bit more somewhere else. And now I need to cube root both sides. Cube root both sides. And that should get rid of this here. Those should cancel out. So now I only have this part here. So I'm going to go back over to my other screen. So again, if you don't have a calculator, you can go ahead and just leave it like that. But if you do have any way of getting a calculator, which if you have internet, again, Desmos works out very well. Let's go ahead and change it again. So go back to functions, last tab, in, and we need cube root of 343 squared. And we get our number, 49. So answer is 49. Go back to the other screen. So x equals 49. And let's see if it works out. I'm going to plug it in really quick. So 49, oh boy. 49 and then cube it and then take the square of it. So that's 49 times 49 times 49. Now this one here, I don't think we can really, I don't know if we can really do it in check it the way we should, but we really should make an effort to check things. So I'm gonna have to write this one out. 49 plus 2, and then I need to put 49 in here, 49 to the 3 power. And we also have to take the root of it, so that's going to be the square root, and it should come out to about 690. So let's try that. Ooh, not 49. I said 49 while I was writing this, and that's probably why I put that there. Okay, 4 plus 2, and there is one other thing I can do, and this is a weird trick, but since we're testing it and we already have the answer, I'm going to kind of do something a little bit different here. And I'm going to go with 7. I'm going to turn 49 into 7 squared. And you're probably wondering, where did that come from? But remember, 7 squared is the same thing as 49. So essentially, I have 2/3. So 2 to 3. So I can multiply that out, or was it? No. All right, yeah, and I would need to multiply that out. So that'd be 7 to the 6th power square root, which would actually be 7 to the 3rd power plus 4. Oh wait, no, times 2 then 4. Oh, this one's, I'm trying something a little bit different than I did this morning. Okay. Let's see if this works out to 690. So 7 times 7 is 343, I think. 343 times 2. And that would be 686. And I still have the plus 4. I'm just sort of working a little bit faster than I could. And 4 plus 686 does equal out to 690. Okay. Like I said, that one's a little bit different than I did this morning. We'd probably need a calculator to check it, but here's how you would check it without the calculator. And that's why I didn't, again, if you remember from before we started this one, I said that the homework is made a little bit easier, but this is something you should be prepared to work on. All right. So we know that this number is the answer here. So we know that it is 49. So this one's probably going to be a similar kind of question. Minus 6, because I want to get this. I want to get this number by itself. This p. So I got to get the 6 out of here. Negative 4 p to the 1/2. Negative and another negative combine to make a bigger negative. So negative 28. Now, one error that I think people make, and I think I made this mistake earlier, is make sure that so if I had a parenthesis, that's 1/2 power of everything in the parenthesis. But when you have a power on one variable, then it only applies to that variable. So in other words, we don't need to square root this 4. And I don't want to confuse you too much, but we did the same thing here when we divided by 2. So I'm going to divide both sides by -4. So negative cancels and the 4 cancels. So I end up with square root of p equals, and now I have to do some division. So -28 divided by -4. So remember, a negative divided by a negative is going to be a positive. So it's not the same thing as adding 2 negatives. When you multiply 2 negatives, make a positive, or same thing with division. So in this case, it would be 7. So now what number can I take the root of to get 7? Now, if I say it like that, you could probably figure out what that number would have to be, the p. P would have to be, well, 49. But let's say you are stuck here, or maybe you want to do everything by the book. I'm going to square both sides on this. So square both sides. By squaring the square root, it's gone, right? It's been eliminated. That's the inverse. So we get 49. And let's plug it in really quick. So square root of 49 is 7. 7 times -4. 7 times -4 is -28. -28 plus 6 is -22. So that one was a lot easier to check. Okay, I didn't need to do all this stuff in the middle right here with this one here. And we have a much easier time with this one, just because we're not dealing with so many powers, right? Because when you get a lot of powers and roots, it can get confusing. But with this one here, I guess, again, I would highly recommend you check everything, but I'm not going to appear behind you if you don't check some of these. So even though this did look like a lot of work, which it kind of was, you don't really need to check all of them. But again, I highly recommend that you do, because by the next lesson, I think it's either Thursday or next week, some of these kind of problems are going to have no solution. So again, you do all the right steps, but somehow you end up with something that has no solution. All right, so we're done with this one. Moving on to the next one. So some of these have, they're done a little bit differently. This one here looks very similar to ones we've done all week, and I kind of mentioned this a little bit earlier, but when I kind of mentioned that when you have 2 terms that are not under a radical and you square both sides, something different is going to happen. All right, so hopefully you had some time to write it down. Let's go ahead and get started. First thing we're going to do is isolate the variable. Now, one thing is very different about this one here, and you might have already noticed that there is something different about this. What's different is this one has 2 variables. Usually when we solve something, so far we've always just had 1 variable. But what happens if you end up with 2 variables? Okay, so I'm gonna square both sides just like we've been doing. And if you square a root, it goes away, it's gone. So now I only have p minus 1. But here is something different. I know some students might say, well, wouldn't it be p squared plus 1? But be careful with that, because in this case, there are two terms. And this parenthesis, because I have to square both sides, and when I say square both sides, I mean everything on both sides. That means we have two sets of this number here. And just like one of the others, I think yesterday we did have some lessons where we did need to use FOIL. So we're gonna have to FOIL these parentheses out. So first step are multiplying the first numbers in each group. So P times P. P times P is P square. And outside numbers, so those are these two numbers here. So P times -1. And I could say -1P, but I'm gonna keep it simple. Third step is the inside terms. So the two closest ones to each other. So this is -1 times P. So it's gonna be another -P. And last step, which also means last, -1 times -1. So -1, negative times a negative is going to be positive, and 1 times 1 is 1. So I end up with just that. Okay, now I need to do some moving numbers around. Now, I'm going to do something a little bit different here, just because on my workspace here, I don't have a whole lot of room. But here's what I'm going to do. I'm going to minus P and plus 1 because I want to get rid of them on this side. So what I'm going to do, instead of putting them down here like you normally would, I'm going to put them over here. So minus P plus 1. Now again, P minus P is 0. So that zeroes out. 1 minus 1 also zeros. So now I have much fewer things to work with. And as another bonus, they're all together. -P, -P, -P. So I can easily rewrite this without having to do a whole nother line of writing stuff over. So work from descending powers. So highest power is P square. I have no other P squares, so it stays there. And going down, P to the 1 power, so that's these three here, -P, -P, -P. So if I combine all of them together, I get -3P. And regular numbers now, so 1 plus 1 is 2. Now it says solve it, which means get the P's by themselves. So we're not done yet. We still got to get these P's by themselves. So you might remember from Algebra 1, and it's covered by most Algebra 1 teachers, and I know I think most of you guys were in my Algebra 1 class. So we're going to have to kind of go back. I know it's a long time ago, and try and solve this quadratic equation. So to solve the quadratic equation, there's a couple of different things. There's a square root property. There is quadratic formula. There's graphing. There's factoring. And there's like a couple of more other ones. But we're going to need the one that's a little bit different. So if you were in my class in the past, I use what I call double bubble method. Sometimes called the Loif method, which is just forward, which is backwards of FOIL. So I'm not really sure. I haven't had anybody say anything about this yet, but it's a pretty, in my opinion, it's probably the easiest one to learn, the easiest one to remember, and it's usually the fastest if you can get whole number factors. So to do this, first thing I do is double bubble. So this is the one where you have to try to pick these numbers apart into two groups that will multiply to 0. All right, so starting with the last number, I have 2. So I need two numbers that multiply to 2, which is pretty easy. 2 and 1 are the only factors I can multiply to get 2. There are no other numbers. Now we have to do the middle part, which I usually combine them together. So outside inside number, which actually in this case is our middle number here. So looking at the sign is going to give us what these signs are going to be. So it's negative. So I need two numbers that will add to -3, but will multiply to +2. And this is pretty easy when you think about it. But they are both going to be negative. And like I said, this is Algebra 1 stuff. I don't know if we need to go back for this. I wish I could ask you in person, see what you say. But we're just gonna have to keep going with what, actually, like I said, I think I took some of these off took them off the homework. All right, but anyway, negative times negative is positive. So -2 times -1 is +2. And -2 plus -1 is -3. So our OI, the inside, becomes the middle. And now our last step is the first step, which is in this case p squared, which there's only one thing I can multiply to get p squared, and that is a set of p. And if you want to check it, use the FOIL method again and see if it works out. P times p is p squared, okay? Outside is -1p. Inside is -2p, so -1, -2 makes -3, so it still works out. And last number, -2, -1, multiply them together, you get +2, so this works out. But we're still not done yet. We got to get these variables all the way by themselves. So I'm going to use zero product property, and I'm going to set them both equal to 0. So 0 equals p minus 2, and 0 equals p minus 1. And from here, you just do a little bit of work, a little bit of algebra, add 2 to both sides, and my first answer is p equals 2. And if I plug it back in to the original equation, so again, you should check these, 2 minus 1, so remember p is 2 now, I'm going to write it here just so it's a little bit easier to see it. 2 minus 1 is 1, square root of 1 is still 1. 1 plus 1 is 2. So that's true. This is a solution. And like I said, if you see two variables or a p square, that's usually a hint that you might have two answers, two solutions. So now I have p equals 1 because I add 1 to both sides. And before we make it a solution, let's check it really quick. So again, I'm going to kind of just go through this process. So p is 1, this p is 1. 1 minus 1 is 0. So there's a 0 under this radical. 0, take the square root of 0, you get 0. 0 plus 1 is 1. That's true. 0 plus 1 is 1. So p can also be 1, or it can be 2. So we end up with two solutions. All right, and like I said, I removed some of the really complicated ones from the homework, but it's also kind of hard to plan ahead. So whenever I make the homework packets, it's usually about a week before we cover them. So sometimes I might not cover certain things, or I might change the lessons, because once I send it out, I can't change it. So I really have to do a lot of planning ahead. And I think after this week, they want the lessons 2 weeks ahead of time. So it's like, I don't know, it's going to be kind of a mess at some days, I think. All right, well, moving on. We still got plenty of time. And again, take a second or two to copy this part down if you're following along, taking notes, which you should be. Biggest lie people tell themselves is, I can remember it later. I don't need to write it down. All right. So now we need to find the number that we can times it by 5, add 1, take the cube root of it, then add 8, so that we get 4. All right, and sometimes you can solve these by trial. You can just pick things until something works out. Well, let's stick with our process that we've been using. First things first, as always, let's see if we can isolate that radical. Isolate that radical, so root 3, 5x plus 1 equals, and then 4 minus 8. 4 minus 8, so that's going to be negative 4. From here, I got to get rid of this cube root. So take the cube root off by cubing both sides. And that should free up what I have under here. So 5x plus 1 equals, and here I end up with a weird thing, something we haven't seen before either until now. Negative 4 times negative 4 times negative 4. So I'm going to use a multiple tree and multiply all these back together. So negative 4 times negative 4 will be 16 times negative 4, which is negative 64. This is a little bit different because remember, if you square a negative number, it'll come out positive. With powers higher than that, it kind of uses a different set of rules. So you can't just say, okay, well, it's going to be negative or positive. So sometimes you just have to work the whole thing out. Or again, when in doubt, write it out. Okay, now we got rid of this cube root. So we continue working on getting that x by itself. So minus 1 from both sides, 5x equals, and negative 65. Now, what number can I multiply by 5 to get negative 65? Let's try dividing both sides by 5, because remember what this means. This means 5 times x. So we have to do the inverse, which is divide. So we divide both sides by 5. And x equals negative 13. Now this morning in my morning class, I made a mistake. I accidentally turned this negative, and I ended up with 2 of them that were different. So I ended up with a different number down here. But again, because I checked it, and hopefully you get good at checking these too, you notice that I noticed that, hey, wait a minute, this doesn't work out. So let's go ahead and check it again, because again, everybody makes mistakes, even me, right? Nobody's perfect. So let's go ahead and try that out. So take negative 13 and plug it in where x is. Again, I'd like to write the whole thing out, but that would take a lot. Just writing it takes a long time. 13 times 5 is negative 65, because I need the negative in there. So negative 65 plus 1 is negative 64. Take the cube root of negative 64, you get negative 4. So all this becomes negative 4. Negative 4 plus 8 is negative 4 plus 8 is the same thing as 8 minus 4. So 8 minus 4 is 4. So this is a solution, it works out. And again, I'd like to write the whole thing out, but it's just not going to work. If you remember, well, if you've been in my classes before, you'll know that my Promethean doesn't work. So it's really hard to write small numbers. I'm just writing everything using a mouse. Okay, so not bad on that one either. All right, so some of these with rational powers. Now this one does have a parenthesis. When it has a parenthesis, that means everything is going to be under a radical together. So be careful. Now that's different than, it's different than something like this where there's no parenthesis. So like that first example we did, we don't really need that parenthesis there. And I'm going to minus 3 from both sides so I can isolate this radical. 5 minus 3 is 2. And we got to take the fourth root. So I think this is one of the first ones. Well, actually, no, we had that one where we took like the fifth root. So sometimes you do just have really, really large roots like this. So I am going to get rid of this fourth root. We do that by raising both sides to the 4 power. And again, power undoes index. And it has to be the same number too. So if it's the 4th index, then you have to make it to the 4th power. And now we have 2 to the 4th power, which we can do this in our hands. 2 times 2 is 4. 4 times 2 is 8, and 8 times 2 is 16. So I have 16 here. And this one right now, it's pretty straightforward. There's no weird stuff going on. So we just take care of it like a regular algebra problem that hopefully you guys are pretty good at by now. 16 plus 2 is 18. And now I need a number that I can times by 3 to get 18. So undo the times by 3 by dividing both sides by 3, and x equals 6. And again, let's check it. Sometimes we just got to use our imagination. 6 times 3 is 18. 18 minus 2 is 16. Fourth root of 16 is 2. 2 plus 3 is 5. So there we go. It is a solution. It works out. That one was actually a pretty fast one. I don't know. Maybe I went too fast on that last one. Or maybe we're just getting better at it. Anyway, next one. Now this one is another one. If you look at it, you notice that we have 2 variables. So this one is probably going to end up being one of the problems that we might end up with 2 solutions. And again, it's not always true. Just because you have 2 variables doesn't always mean you have 2 solutions. But that's why you kind of have to know your way around to see what's going on. So let's go ahead and I'm going to add r to both sides. And I'm also going to minus 2 to both sides. So r and minus 2. So I got to get rid of this r, got to get rid of this 2. Because we are going to have to get this r out from under the radical, r minus 2. So to get rid of the radical, because again, I got to get both of these r's. If I can get them together, that would be pretty good also. But because I have 2 separate numbers on this side, I'm sorry, 2 terms. Well, they technically are numbers, but we call them terms. This means that I have 2 sets of that negative also. So my radical is gone on this side. R minus 2 times R minus 2. Because again, that 2 power means I have 2 sets of both of these things. Now we're going to have to use our FOIL. So r plus 4 equals now first number, so r times r, first number in each set. So that would be r squared. Outside numbers, so the 2 outer numbers, so negative 2r, because r times negative 2 is negative 2r. Inside numbers, so negative 2 times r is going to be also negative 2r. And last numbers, 2, well, don't forget that these negatives also have to go with the number also. So that's negative 2 and negative 2. So negative times negative is going to be positive. Which again, if you remember from factoring, sometimes you got to pay attention to these signs, and there are special things you got to watch out for. Now I'm going to do the same thing I did on that other slide just to save some space. If you want to rewrite an entire line again, go ahead, but I'm using a mouse. My hand's going to get tired if I keep writing all this stuff. So minus r minus 4. And I'm going to put it over here, minus r minus 4, which normally I know most teachers and anybody else would put them on the bottom. But when you put them all up here, they're all one line, and it's a little bit easier to combine many terms. So I don't need to write this whole line again after I add these two things up. So let's go ahead and go down the powers, r squared minus, and then work with the next one. So negative 2, negative 1. So that would be negative 5r. And 4 minus 4. So 4 minus 4 is 0. And I don't really need that 0 in there. The 0 doesn't really add anything. It doesn't really contribute anything. But we still have a square number. Now, we could use the double bubble method where we have 2 sets of parentheses. But that works best when you have 3 terms. A trinomial is what we call it. A quadratic trinomial. But in this case, I only have 2 terms. Now, this one's a little bit tricky because it's easy, but I think people kind of forget the idea behind it. So what's going to happen with this one is we are going to use opposite of distributive property. So people are used to distributive property pretty well. They know when there's a parenthesis and the number on the outside is multiplying, you multiply everything to that number on the outside. But in this case here, we're taking it away. We want to take these numbers out, as many as we can. In this case, I only have r's. Both numbers have r's. So I'm going to take their r. This first guy had 2 r's. Now he has 1 r. This guy had a 5 and an r, but we took out the r, so now he only has 5. Now from here, 0 equals r. I'm going to do the same thing. I'm going to split up the factors. So split them. So 0 equals r and 0 equals r minus 5. Now that's an r. It kind of looks like a little tiny radical. But anyway, now we have our answers. R equals 0 and r. Well, to get this one, I just need to add 5 to both sides. Plus 5 here, plus 5 there. And there's a pretty easy pattern to that as well. Once you kind of see it, it's a lot easier to see how it works. And there you go. We are done with this one. I think there's one more, and then we're going to be done with this one here. So see how that works on. And don't forget, also, these lessons are made into videos. So if you miss a part, you can always go back and play them again. Or if you missed the lesson, then this can be your lesson here. So I always have the videos uploaded before I leave for the day. If you have any more questions, after watching the video, I think I'm going to try to have a tutoring session on Fridays if I can. it's a bit of a stretch, a bit of a push, but I think on Fridays there's going to be some time that we have where there's no classes. I might do like a morning session and an evening session or an afternoon session, but we'll try to get that tutoring session on Friday. If not, well, okay, I'll have to think of something else because I know some of you students are having troubles following along, following the lessons. You know, spotty internet, bad internet, whatever. I know it's like that in places. I wish there was something else we could do because again, I am getting emails from you guys saying, you know, I need more help, and that's tough to do even during a normal school year. You know, so it now doesn't make, with everything going on, it really doesn't make it any easier. So I'm going to try that. So what my suggestion to you would be is to try your best, try doing as much of the packet as you can. Maybe mark some of the ones that are giving you trouble. Maybe there are some you think you have the right answer, but you want to make sure before turning it in anyway. All right, just save those ones. We'll go over them on Friday if we have time, if you can make it, and I'll do some on the board, and you know, that way it's a lot easier for me to write, or maybe we can just do it on here. All right, but again, try as many as you can and save the ones you can't, so that way we can focus on those ones mostly. All right, so here we go. I kind of got started with this one already. Get rid of the cube root, cube both sides. So in this case, cubing both sides worked out because they both had a cube root. Now that cube root is out of the picture. So now I only have to work with the numbers on the inside. And again, here it's like regular algebra problems. I want the x on the left side, right? We want it on this first side. And we also want to keep it positive, so it makes sense to minus 3x. Because if I minus 4x from both sides, it would be on this side and it would be negative. So it works out pretty well like that. And now I have much fewer things to work with. And this is a pretty easy, straightforward problem. I don't know why this is the last problem. I don't know. Maybe they wanted to put us in a good mood before we left. All right. You got to be in a good mood sometimes before you leave. Now, all right, I'm going to use this line to check it because I already know on this side they are already equal, but I don't want to have to cube both sides. If I cube both sides, it's just unnecessary work. So let's try that out. 4 times 5 because I plug x in as 5. 4 times 5 is 20. 20 minus 3 is 17. Okay, so this side is 17. Plug in 5 here, so 5 times 3 is 15. 15 plus 2 is 17, so it works. Anyway, oopsie. Wrong button. All right, I think that's going to be it for today as lesson wise. Let's see, how was it I get back? Oh, okay, let me just double check my attendance.